Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue my series on simulating cards in Sugarcube and Twine. As you can see, I have a program that is very similar to the small program that I was demonstrating in my last video, which deals you a hand of 5 cards. But there is something new. It now tells me how that hand ranks in terms of poker hands. In this particular case, it's saying you have a pair, and it's right. I have 2 4s, and I can choose restart, and it will tell me I have nothing, which is true. If I look, I don't have any pairs or anything. I don't have a straight. I don't have a flush, and I can keep doing that, and it will always give me. Well, that gave me 2 pairs, 2 kings and 2 2s, and so on. It will always tell me. What I've got, and it can also integrate jokers. So, for example, here we have a pair of kings, but we also have a joker, and we can count the joker as a king, and therefore that counts as 3 of a kind. So let's have a look at the code that allows that to happen. There's only one new page compared to last time. There are several new variables that we should look at. There's actually one variable that I got rid of as well. I had $C0, which was the number of cards in the draw deck, $C1, which is the number of cards in hand, and $C2, which was the number of cards in the discard pile. However, I also had $H, which was an array with the details of the cards, but H.length was the number of cards in the player's hand. But that's the same information as $C1. So I realised I don't need C1, and I got rid of it. That's why we go from C0 to C2 without having any C1. However, let's look at the new variables. There's 4 that are most important, I think. There's $HM, $HP, and $HS, and they are all arrays. And then we have $OK, which is a single number. $HM gives you the number of different combinations. So $HM2 is the number of pairs, $HM3 is the number of 3 of a kind, $HM4 is the number of 4 of a kinds. Technically, if we were using that system, we could say that $HM1 would be the number of 1 of a kinds, i.e. the number of cards that don't have anything of the same numeric value. But there's no point keeping track of that because that doesn't count as a hand in poker or anything. So we only use 2, 3, and 4. $HP gives the number of cards of a given numeric value. So $HP7 is the number of 7s that you have in your hand, for example. And in this one, $HP0 is used for the number of jokers. And $HS is very similar to $HP, but it's it groups them by suit. So $HS0 is the number of spades, $HS1 is the number of hearts, 2 is the number of diamonds, 3 is the number of clubs. And you'll find that numbering is the same as is used in the $SN array, which gives the names of the suits. Normally, you notice from this that it starts from slot 0, this one here. Normally I don't do that. I find it counterintuitive. I like to start from slot 1, but the maths is a bit easier if I start from 0, basically. So in this case, I did start from 0. And because 0 is the number of spades, HS minus 1 rather than HS0 is the number of jokers. And then we have this numeric one, which is $OK. So it's the highest, it's the number of cards in the largest combination. So what I mean by that is if OK is equal to 3, then that means the hand has a 3 of a kind. If it's equal to 4, you've got a 4 of a kind. If it's equal to 2, you've got a pair. Again, technically, if you didn't have anything, it should be equal to 1 because you've always got 1 of a kind. But again, there's no point keeping track of those. So in fact, if you don't have a pair, OK will be equal to 0. So I will skip over these three because we've already talked about them. Card details, I will just say very quickly what it does, not why the maths works. What it does is you have a number stored in the H array, or numbers stored in the H array, which represent the cards that you've been given, but they don't store it as like 7 of diamonds or queen of spades or 4 of clubs. It just stores it as a number. So you might have 32, 50, 17, etc. Just a number from 1 to 54, because that's the number of cards in the deck that we're using. We're using a 52 card deck plus 2 jokers. And so for particular purposes, we have to say, well, how many do we have a pair of kings? How many kings do we have, etc. We need to turn that number of the card, that single number, into a suit and a numeric value. And also for the purposes of display, into a file name as well, so we can know which picture to look at. But in this case, we don't need the file name. We just need the suit, which is $S, and the numeric value, which is $P. And it does it basically by mathematical formula. There's a couple of special bits of code for the 2 jokers, but most of the time it's just a formula that works out. Given 17, it can say, okay, that's the 4 of, I think that's the 4 of hearts. So let's go through this page, which is the new, where most of the new material is. So in the program as written, we don't need to do this. We don't need to reset these arrays because we're only dealing with one hand. It just deals one. Currently, it just deals one hand and then tells you what you've got, if anything. But of course, in a real game, you would be dealing with multiple hands. So you would need to make sure that those arrays are reset each time. So we have a series of for loops, and they go through the relevant slots of these 3 different arrays, and they set the relevant slot. They set all the slots that might be used to 0. The only difference is the name of the array that we're dealing with and the range of numbers, because different slots are used in different arrays. In HMZ, we go from 2 to 4. In HS, we go from -1 to 3. And in HP, we go from 0 to 13. Having set all those to 0, having reset them, we now have to find their current values with the current hand. So we have a for loop that goes from 0 to h.length. In other words, it goes through every slot that is in use of the $H array, every card that's in the hand. And again, with $H, I started from 0, where normally I start from 1. It just makes it easier to do this h.length command if you start from 0. So that's why I made an exception to my normal practice. We set Z equal to $H, $Y. We include card details because card details extracts its information from Z. So we set Z equal to $H, $Y. Now, we've called card details twice, and both of the time we're getting Z from $H, $Y. So with the program written as it is, we could just not worry about Z and just put $H, $Y with each instance of Z. But I haven't done it that way because just in case we ever call it, and it doesn't use the $H array. I don't know if that would happen, but it's probably best practice not to assume and just to have a special variable. And if we get Z from somewhere else, where we can just say in that page, before we call card details, we just say set Z equals wherever we're getting it from, and then we can call it, and that means we don't have to change card details. All right, so we get $P and $S, $P being the numeric value, $S being the suit, and we add 1 to the relevant slot of $HP and $HS. So $HP square bracket, $P end square bracket, and $HS square bracket, $S end square bracket, plus plus, which just means set them equal to their current value plus 1. Because that's often done, that's often how you change a variable, they have a special shortcut for that. And also minus minus, which is subtract 1 from its current value. But plus plus is probably used more often because you're adding 1 to things more often in my experience. So after this for loop, after we've gone through the whole hand, we'll know how much, or the program will know how much of each suit we have and how much of each numeric value. And because we've got that information, specifically because we've got HP, we can fill in HM. Remember that HM is the number of pairs, 3 of a kinds and 4 of a kinds, if any. And for that, we need to know, of course, how many we've got of each number. So we have a for loop that goes from 1 to 13. If the relevant slot of $HP is greater than 1, then we set $HM, square bracket, $HP, square bracket, $Z, n square bracket, plus plus. Again, we add 1 to it. So let me give you an example. Let's say Z was 7, and we find that HP7 is equal to 2. Then we would set $HM, square bracket, $HP, square bracket, Zn square bracket, but we know that that would be 2. So we'd set $HM2 plus plus. In other words, we'd increment $HP2 by 1 to indicate that we had 1 more pair. Now, technically, of course, you could say that if you have a 3 of a kind, you also have a pair. In other words, in fact, you have 3 pairs, I suppose you could say, because each of the, you can make 3 different pairs out of the 3 of a kind. But the way that we're treating $HM, if it finds a 3 of a kind, it will increment HM3 and not increment HM2. So it counts 3 of a kinds as not being pairs, even though they technically means that there is a pair. And similarly, it counts 4 of a kinds as not being 3 of a kinds or pairs, even though technically they are. So once we've gone through that for loop, we know whether we've got any pairs, 3 of a kinds or 4 of a kinds, and if so, how many. With a hand of 5, we can only have 1 3 of a kind and 1 4 of a kind, but with larger hands, we would be able to have more. And I tried to make this general to any hand size. I may have missed out on some corner cases, but I think I've done that. So anyway, now we need to determine $OK, and that is based on the HM array and the number of jokers, which is $HP0. We could also use $HS minus 1, of course. They're both the number of jokers, but just arbitrarily decided to use that one. All right, so this is an example of dealing with hand sizes other than 5. If $HP0 is equal to $H length, well, that means if the number of jokers that you have is equal to your hand size. Now, there's only 2 jokers, so how can the number of jokers be equal to our hand size of 5? Well, with a hand size of 5, it can't. But with smaller hand sizes, it could be. If we had a hand of 2 cards, then this could be the case. So I programmed for that possibility. If that is the case, then we set $OK equal to $HP0. So what that means is, let's say all of our cards are jokers. So we've got say 2 jokers and nothing else. Then the highest value, the highest thing we've got is a pair, which is the 2 jokers. And we can say that that's 2 anythings, 2 aces, 2 kings, whatever, but it counts as a pair. If that's not the case, if HP0 is not equal to H.length, and that will always mean that H.length is greater than HP0 because you can't have more jokers than you have a hand size. You can't have 3 jokers in a hand of 2 cards or one joker in a hand of 0 cards. So in every other possibility, $OK is equal to HP0 plus 1. So why is it plus 1? Well, let's say you have a single joker. If you have a single joker, then you have at least a pair, because you can always match the joker with one of the other cards. If you have two jokers, which is very rare, but we need to program for that possibility. If you have two jokers, then you have at least a 3 of a kind, because you can pair those two jokers with any of the other cards, if you've got other cards, that is. And that's why we set OK equal to HP0 plus 1. So actually, I think I said in the introduction that OK is set to 0 if you don't have any pairs or anything. But actually, it now that I look at it, it would be set to 1. It would be set to 1 if you had no jokers. It would be set to 1. But that doesn't matter. It's only ever dealt with if it's got a value of 2 or higher. So now we know OK. We know the highest. We know the highest pair, or we know the highest size combination that we have. We know how many pairs we have. We know how many 3 of a kinds we have. We know how many 4 of a kinds we have. That's all stored in HM. But we do. Sorry, we will know that. Sorry, we will know that once we go through the pairs and stuff. Sorry about that. I got the order a bit wrong. Okay, so we have a for loop that goes from 2 to 4. If $HMZ is greater than 0, so let's say Z is 2. If HM2 is greater than 0, that means we have at least one pair. Then we set OK equal to Z plus HP0, which is the number of jokers. So let's say HM2 is over 0, then we would set $OK equal to 2 plus the number of jokers. Because if we have a pair, that's a pair. If we have a pair and a joker, that's a 3 of a kind. And if we have a pair and 2 jokers, that's a 4 of a kind. Or it's at least that. We might also have a 3 of a kind. So that's why we use that set OK equal to $Z plus $HP. And if we have both a pair and a 3 of a kind, which can rarely happen, it's a combination called a full house. Because it'll do 2 first and then it'll do 3, it'll overwrite the value. It'll start with 2 plus the number of jokers, and the next run through it'll do 3 plus the number of jokers. And that's the one we want. We want the larger one. Okay, so now this is when I should have said the thing that I started to say before. Now we know how many pairs, how many 3 of a kinds, how many 4 of a kinds we have, and we know the number of cards in the highest combination we have. That is almost enough. We also need to know whether we have a flush, and we also need to know whether we have a straight. A flush is... what is a flush? A flush is 5 cards of the same suit, or at least 5 cards of the same suit, and you can substitute a joker. I say at least 5 cards because, again, you could have more than 5 cards in your hand. And in that case, you don't have to have, let's say you have a hand of 6 cards. To get a flush, you don't have to have 6 of the same suit. You just need to have 5, or 4 plus a joker, or 3 plus 2 jokers. All right. Flushes are very rare, and so are straights, the next thing we're going to look at. Unfortunately, the way poker works is it has a very large hierarchy of hands, but you almost never get most of them. Really, most of the time you'll get nothing or a pair, and then sometimes you get 3 of a kind. Maybe you get 3 of a kind or 2 pairs. Really, that's all you ever see. Anything else is really, really rare, but it has all of these other possible things which are sort of better and better, and which only happen like one time in 10,000. But because we want to cover all of them, we have to have programming for it. So it's a little annoying. We have to have this quite long bit of code for something that's almost never going to happen. All right. So what we do is we set Z2 equal to 0. We're going to set it to 1 if the hand has a flush. Here is the code. Sorry, that didn't cover the right bits. Okay, so there is the code. It goes from, it's a for loop from 0 to 3. Each of them is a different suit because we number the suits from 0 to 3, not 1 to 4, as discussed. If $HS, $Z, so if the number of cards of that suit plus $HS minus 1, and $HS minus 1 is just the number of jokers. Now, I could have used, you notice that I used $HS, I used $HP0 for the number of jokers here, and I used $HS minus 1 for the number of jokers here. I could have swapped either of those. It's just because I was using HS, I used HS again. There's no real reason why. But if the number of cards you've got of a given suit plus the number of jokers you've got is greater than 4, then we set Z2, and I've just realised I stuffed that up. There we go. Okay, sorry, that was I kept something from an old version. Okay, so if $HS, $Z, which is the number of cards of the suit that we're looking at, plus the number of jokers, is greater than 4. I didn't say equal to 5 because you might have a 7 card hand, and you might have 6 cards of the same suit. Well, that still counts as a flush. You have to have at least 5. In fact, I might specify that just in case there's some confusion. I don't know how familiar people are with poker these days. Basically, I don't know whether young people still learn how to play poker. But anyway, if that's the case, then we set Z2 equal to 1, and that tells us whether we have a flush. Now, that's not very long. The code for a straight is much longer. A straight is a sequence of cards. This is to do with numbers, not suits. It's a sequence of consecutive numbers. So if you have a 2, a 3, a 4, a 5, and a 6, that is a straight. And specifically, they're usually numbered from the highest one. So that would be a 6 high straight. And there's a little complication, which is an ace, as it says here in the notes, an ace can count as lower than 2 or higher than a king, but not both. So what that means is ace 2, 3, 4, 5 is a straight, ace, king, queen, jack, 10 is a straight, but king, ace 2, 3, 4 is not a straight. In other words, you can't sort of wrap around. You have to treat the ace as being 1 or as being the number above the king. You can't treat it as both in the same hand. And again, jokers can substitute for any missing card. So we go from 1 to 10. These are the lowest. These are the possible lowest values of a straight. We don't do 11 because that would be 11, 12, 13, 14, 15, and 14 is sort of, that's the ace, but there's nothing beyond that. So that's why it's 1 to 10. So we're going to look at whether there's a straight with Z as the lowest card. We set Y equal to 0. Y is the number of values missing. So in other words, we're going to start with 1, and that will mean that we look at 1, 2, 3, 4, and 5, and we'll say, have we got any ones? That is to say, any aces? Yes, no. Have we got any 2s? Have we got any 3s? Have we got any 4s? Have we got any 5s? And every time the answer is no, we don't have any of those, then we will add 1 to the value of Y. So we have another for loop, and it goes from Z to Z plus 4. In other words, from the highest number, from the lowest number in this potential straight to that number plus 4. So in the case of 1, it'll go, in the case of Z equals 1, it'll go from 1 to 5, because they're the numbers we're looking at. Ace, 2, 3, 4, and 5. Do we have an ace, a 2, a 3, a 4, and a 5? And because Z goes from 1 to 10, and X goes up to Z plus 4, well, X can have a value of 14. but there's only 13. There's only 13 different numeric values. So what do we do when x is 14? Well, in that case, that'll be when z is 10, and then we're looking for 10, jack, queen, king, ace. So if x is 14, then we look at $HP 1. And I've just realised... Oh, no, that is correct. Sorry. I was going to say I've just realised that I made a mistake, but I got confused with aces and jokers. All right. So if x is 14, in other words, we're looking for a 14, which is to say an ace, and the number of aces that we have is 0, well, that's a missing number, isn't it? So we increment y. If x is less than 14 and $HP x is equal to 0, so let's say x is 7, well, that means we're looking for 7s. If HP 7 is 0, let's say we're looking for 5, 6, 7, 8, 9 as a straight, then that's a missing number, and we set y equal to 1 more than its current value. Then, once we've looped through all these values from z to z plus 4, we ask, is y less than or equal to $HP 0? In other words, is the number of missing pieces, the number of missing cards, the number of missing numeric values, is that less than or equal to the number of jokers? Because we can plug each of those gaps with a single joker, but we can't plug 2 gaps with the 1 joker. We can only plug each, one joker can only plug each gap. So if y is less than or equal to HP 0, which will always be true if y is 0, i.e. we've got all the cards in the straight, but if we have one missing, we need at least 1 joker. Then we've got a straight. If that is the case, we have a straight and we set y2 equal to 1, and then we continue with the for loop. We reset y to 0, and we look for the new straight, the one that starts from the new value of z to the new value of z plus 4. And then now we're in the home stretch. This is really the bit where we just go down the hands, the different types of hands in order from top to bottom. And if you've got the one at the top, we say, yep, you've got, oh no, you know what? I've got it again. We're not in the home stretch. Okay. Now there is a complexity, which is that there is a straight, there is a flush, and there is another hand called a straight flush. And that means that you have 5 cards that form a straight, i.e. a run of numbers, and also a flush, i.e. they're in the same suit. So if you have a straight and you have a flush, you might have a straight flush. But you might not, because remember, you might have more than 5 cards. So here's an example. I mean, this is very rare, but again, we've got a program for all the possibilities. So let's say here is a straight. Let's say we have a hand of 6 cards, and they're an ace, a 2, a 3, a 4, a 5, and a 9. And let's say they're the 2 of hearts. Let's say we have the ace of spades, the 2 of hearts, the 3 of hearts, the 4 of hearts, the 5 of hearts, and the 9 of hearts. Well, in that case, we have a straight, ace, 2, 3, 4, 5. And we have a flush, hearts, 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 hearts. But we don't have a straight flush, because our straight, ace, 2, 3, 4, 5, is not all the same suit. And our flush, heart, 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 is not in, it doesn't form a straight. It's 2, 3, 4, 5, 9. So it's possible, if you have 5 cards, then the 5 cards that make the straight and the 5 cards that make the flush must necessarily be the same cards, because you've only got 5. But if you have more than 5 cards, you may have a straight and a flush, but not a straight flush. That would probably happen one time in every 100,000 hands, I think. But again, we've got a program for it. So if y2 is equal to 1 and z2 is equal to 1, if h.length is equal to 5, then we set x2 equal to 1, x2 being the flag that tells us whether we have a straight flush. Otherwise, we do some code that I can't be bothered to write right now because the chance of having a straight and a flush but not a straight flush is 0 if you have a hand of 5 cards, and we're dealing with 5 cards at the moment. And the chance of any given hand this being relevant, and the code is so convoluted that I thought it would be distracting and pointless to show you that code. It'd be a whole bunch of code that we're never ever going to use. So I will put that in later, but at the moment, I just put that note. So if we've got a hand of 5, then if we've got a straight and a flush, we've automatically got a straight flush. Okay, now we're on the home stretch. Having done all that, we just go through all of the possible hands from best to worst. We test whether they've got it. If they do, we give them the relevant message, and then if not, we just keep going. Remember that, as I said before, the code starts up here, goes down to here, and really most of the time it'll be one of these two. And then rarely it'll be one of those two. And the rest of them are, vanishingly rare. For some reason, poker, people thought it was fun to add all these really rare, brilliant hands. But, they don't really come up very often. All right. So if OK equals 5, in other words, the largest set that we have is a set of 5, and that can only happen with at least one joker, then it says you have 5 of a kind. Otherwise, or else if x2 equals 1, you have a straight flush. Else if OK equals 4, you have 4 of a kind. This is the order of hands in poker, by the way. Else if HM2 is over 0, that means we have at least one pair, and HM3 is over 0, we have at least one 3 of a kind. You have a full house. That's what a full house is. It's a pair of one suit and a 3 of a kind of the other. Else if HM2 is greater than 1 and HP0 is equal to 1, well, that's that we have at least two pairs and one joker, because 2 pairs and 1 joker, you combine the joker with one of the 2 pairs, and that makes a full house. Else, if HM2 is greater than 0 and HP0 is equal to 2 and h.length is greater than 4. So we have at least one pair, we have at least 2 jokers, and we have at least one other card. The hand size is greater than 4. So we have at least one pair, we have at least 2 jokers, and we have at least one other card. Because if you have a pair and another card and 2 jokers, so let's say I have 2 7s, an 8 and 2 jokers, I combine one of the jokers with the 2 7s and the other joker with the 8, and that makes a 3 of a kind and a pair. Else if Z2 equals 1, you have a flush. Else if Y2 equals 1, you have a straight. Else if OK equals 3, you have 3 of a kind. Else if HM2 is greater than 1, you have 2 pairs. Else if OK equals 2, you have a pair. Else you have nothing. And so that will run down all of the poker hands in order and tell you what you've got. Now, in an actual game of poker, there's a quite elaborate system for breaking ties, which we would need to program. And of course, we would need to program how the other players behave. But it is a start. And we can have at least a simple simulation. If not a simulation of poker, at least we can have those. I don't know if you have poker machines or pokies, that's what they call them in my home country of Australia, which are these sort of gambling machines where it gives you 5, it's computerized, and it gives you little pictures of 5 cards, and then you throw out the ones you don't want, and then you get a payout based on the hand that you have. we can at least have something of that sort of complexity. As I say, everything above about here is pretty much never going to happen, at least if you're dealing with a situation like this where you just get a single hand. Normally in poker, you get, or at least this sort of poker, you get a hand and then you can throw out as many cards as you want and get replacements. That's what we will be dealing with in the next video. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.